Good morning, dear students. Let's continue our next topic, total energy. In case of thermodynamics, total energy is the combination of kinetic energy and potential energy. Kinetic energy is the energy possessed by a body due to its motion. And what is potential energy? Energy exists due to its position. And potential energy is of two types, gravitational potential and electrostatic potential energy. Okay. Now we have one more energy, and this is internal energy. Internal energy, and this internal energy is due to molecular level energy. Clear? Students, suppose that if our system is at rest, if the system is at rest, then the kinetic energy is 0, and suppose there is no gravitational field, then our potential energy is also 0. What about total energy? Then the total energy of the system is equal to internal energy of the system. Clear? Now, take an exceptional case, special case for ideal gas. As we all know, there is no force of attraction among molecules. If there is no force of attraction among molecules, then in case of ideal gas, then there is no potential energy, and total energy is only due to internal energy. Total energy is only due to internal energy of the gas, or you can say that in case of internal energy also we don't have any force of attraction between molecules, so that they don't possess any kind of potential energy, and the energy is totally due to kinetic energy of these molecules. Clear? Now come to the degree of freedom. Our next topic is degree of freedom. In case of monoatomic gases, as you all know, in case of monoatomic gases have only one atom. For example, helium, neon, argon, krypton, all these are the monoatomic gases. In case of monoatomic gases, molecules vibrate along x-axis, y-axis and z-axis independently. They don't depend on any other thing. Degree of freedom is equal to, what is degree of freedom? It is equal to number of independent terms in terms of kinetic energy. Number of independent terms, the terms which never depend on anything. In case of monoatomic gases, the degree of freedom is equal to 3. As you all know, degree of freedom is denoted by small f, and in case of monoatomic gases, degree of freedom has value 3. And in case of diatomic degree of freedom, we have degree of freedom is equal to 5. In case of triatomic, or you can say that polyatomic gases, we have degree of freedom is equal to 6. Now, switch to next topic, and the topic is law of equipartition of energy. What is law of equipartition of energy? It states that the average kinetic energy associated with each molecule with each degree of freedom is equal to half kT. कोई भी मॉलिक्यूल है, चाहे मोनो चाहे डाई, उसमें एवरेज काइनेटिक एनर्जी किसके इक्वल होने वाली है? विद ईच डिग्री ऑफ फ्रीडम इज इक्वल टू हाफ kT. अब देखिए, हाफ kT लिख दिया हमने. वन मॉलिक्यूल के केस में वो कितनी थी? 3/2 kT. What 3 represent? 3 represent here degree of freedom. Then the value of average kinetic energy is F/2 kT, where K is degree of freedom. For 1 mole of gas, we have 3/2 kT cross N, and where N is 1, and we get 3/2 RT. Clear? For 1 mole of gas, we can see that we have F/2 RT. Put the value of N. If we have 1 mole of gas, then 1, 2, 2. Kinetic energy for n mole of gases, we have N multiply F/2 RT. This is the expression of energy for n number of moles. Now, let's come to a numerical. Find the kinetic energy of 2 moles of hydrogen at 300 Kelvin. Kinetic energy find out करनी है बेटा 2 moles of गैस के लिए 2 मोल्स, n कितना है 2 मोल्स, हाइड्रोजन एट 300 केल्विन, टेम्परेचर कितना है 300. वी विल राइट द फॉर्मूला फर्स्ट फॉर काइनेटिक एनर्जी एंड इट इज n क्रॉस f by 2 RT where n is 2. Degree of freedom is 5 in case of 2 moles of hydrogen H2. It represents diatomic gas and is, as you all know, for diatomic gases we have degree of freedom is equal to 2. Put this value. We have degree of freedom is 5. Put this value here. And what is the value of R? R is gas constant and we have the value 8.314 per mole per Kelvin. And we will put the value of temperature 300 Kelvin, Kelvin to Kelvin cut, and we get 2 to 2 cut 5 cross 8.34 into 300 per mole. Clear? Thank you, dear students. If you have any query, then please ask from me. Have a nice day.